Okay, today we are going to be dividing fractions by another fraction. And there are some words that I've been saying, but I wanted to make sure that I pointed out to you. Even though I've been saying it, we haven't really talked formally about it. When you have a division problem, what you're dividing into is called the dividend. What you're dividing by is the divisor, and the answer is the quotient. So let's say I had 12 divided by 2 equals 6. The dividend would be 12, the divisor, what we're dividing by, is 2, and the answer to a division problem is called a quotient. So just some vocabulary for you. Let's start with a little bit of a review. You should know by now that you can divide a fraction by a whole number. This is what we did a few days ago, a fraction by a whole number. So if we had 3/4, so 3/4, and we wanted to split it into by 3 people. So again, I like to make up word problems. So if I had 3/4 of a pan brownies and I was splitting it between 3 of us, what would that look like? So I'm taking 3/4 of the pan and then I'm dividing it into thirds. So the first person would get this amount, the second person would get this amount, and the third person would get this amount. So each person is getting 3 pieces of the total 1, 2, 3, 4, 5, 6, 7, 8, 9. We have to split this as well, 10, 11, 12. So 3/12, and 3/12, 3 goes into both of those, so 3 divided by 3 is 1, and 12 divided by 3 is 4. So each person got 1/4 of the pan. Now, let's talk about the formal algorithm. We've been doing that, but today we're going to make it a little bit more formal. So the algorithm just means the rule. So what we can also think of this as 3/4, 3/4 times 1/3. So we had talked last week about how we can flip that number. We're really taking 1/3 of 3/4 and then multiply across. 3 times 1 is 1, 4 times 3 is 12, 3 times 1 is 3, 4 times 3 is 12, and then we can simplify to our 1/4. So the algorithm, the rule, the way we can divide without models looks like this. We also know from the last lesson that we can divide whole numbers by a fraction. So 3 wholes divided by 3/4. Again, remember what this is asking. This is asking how many times does 3/4 fit into 3 wholes. So we have 3/4 once, 3/4 twice, and let me point out before I continue that each of these are wholes, and then I am representing each whole as fourths down here. So we have 3/4, 3/4, 3/4, and 3/4. So 3/4 fit into 3, 1, 2, 3, 4 times. So 3 divided by 3/4 is 4. Now the algorithm, again, that's the rule, how we can do this without the model, is we can change it to a multiplication problem. And remember we talked about flipping or taking the reciprocal of that number, so 4/3. I'm going to change this to 3/1. 3 goes into 3 once, 3 goes into 3 once, and then we can multiply straight across, so it is 4/1 or just 4. So we can use a model or we can use the rule, the algorithm. Now let's try the same idea with a fraction and a fraction, dividing a fraction by a fraction. Jada had 1/2 of a pound of chocolate. She decided to divide the chocolate into pieces that are 1/4 pound each. So she started with 1/2 of a pound, and she wanted each piece to be 1/4 of a pound. So we're seeing how many times does 1/4 fit into 1/2. So here is my 1/2. So we're seeing this is how much we have right now, 1/2, and how many times would 1/4 fit into that. So I'm going to take my second model and I'm going to divide it into fourths. So I can see that 2 1/4 fits into 1/2. 2 1/4 fits into 1/2. So my answer is 2, because 1/4 fits into 1/2 2 times. Now the algorithm, if we follow the pattern that we have been doing before, we're changing that division to multiplication, and we're flipping that second number, and then multiplying or reducing first. 1 times 4 is 4, 2 times 1 is 2, and so we still come up with 2. So you might want to still use the model, and you will have to it sometimes. Pictures always help with word problems, but we also have this algorithm to fall back on. Let's try one more problem before we get into a couple more vocabulary words. So Connie has 3/4 of a pizza. So here's my pizza, and he has, I'm going to split it into fourths, and he has 3/4 of it. And then the second one I have to split into eighths. So here are my fourths, and then I split each one in half. And so now I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. And my 3/4, we can see that there's 2, 4, 6 of them. So there are 6 1/8 and 3/4. So let's see if the algorithm or the rule works out the same way. And I don't know if you can hear my husband yelling upstairs at the Packer game or not. So if you can, I apologize. 3/4 divided by 1/8. We're going to keep the first number. We're going to change the division to multiplication, and we're going to flip that second number. And again, I'll talk about vocabulary in a minute. So I see that I can, 4 goes into 4 once, 4 goes into 8 2 times, 3 times 2 is 6, so it worked. Our model and our algorithm rule, the number sentence we wrote, turned out to be the same answer. Yay! Alright, so let's talk about some vocabulary. Sometimes using a model is not the most efficient way, though anytime I have a word problem, I really do like drawing pictures to help with my understanding, to see what it's really asking me to do. The algorithm or the rule for dividing fractions, the easy way to do it is to just change the divisor, so what we're dividing by, to its multiplicative inverse. Multiplicative inverse is one of my favorite words to say, multiplicative inverse, or the reciprocal. It's where you flip them and then you multiply. So multiplicative inverses multiply to 1. So that's something that's important for you to know too. You're just reversing the order. The numerator becomes the denominator becomes the numerator. Multiplicative inverses. So before we do some more division, let's just name the multiplicative inverse. And again, it's the same thing as reciprocal. Reciprocal. So my numerator becomes my denominator, and my denominator becomes my numerator. So 4/3. And again, I said they multiply to 1. That's how you can tell if you did this right. Times 4/3 becomes 12 over 12, which is 1. So multiplicative inverses multiply to 1, and we can use this to help change our division to multiplication. Alright, so I want you to pause this and see if you can name the rest of these multiplicative inverses. Alright, so it's really easy because you're just switching the location. The numerator becomes the denominator becomes the numerator. So did you get these right? This is a y, not a 4. Alright, now let's use that to do some division of fractions. Alright, I have some like a little cheat sheet over here for you as well. You invert or write the fraction that you're dividing by, you're flipping that, you're multiplying, and then you're simplifying. Another way we can think of this, and you might have heard this before, is keep, change, flip. Keep, change, flip. So we're going to keep the first number. You never, ever, ever, ever change the first number. Change this to multiplication and flip this and then multiply. So we're going to keep the first one, change division to multiplication, and flip the second number and then multiply across. So 1 times 3 is 3, 2 times 2 is 4, and that's your answer. So we're going to keep the first number, change division to multiplication, and flip that second number. Now I like to simplify first. So some people like to multiply across first. I like to simplify. So I always look to see if there's something in the numerator or denominator that I can simplify. 4 goes into 4 once, 4 goes into 4 once. Now I can multiply across. 1 times 5 is 5, 7 times 1 is 7. It's in simplest form. Alright, please pause and see if you can do this one on your own. By the way, I really hope that you are doing as I've asked and you're not just watching this, but you're actually physically taking notes. That helps you stay on task and helps make those connections in your brain. Okay, so I already rewrote the problem. I kept the first number, I changed the division to multiplication, and I flipped that second number to its multiplicative inverse. And now I'm going to multiply across. 9 times 3 is 27, 13 times 1 is 13. But now this is an improper fraction, so I need to change it to a mixed number. So 13 goes into 27 2 times. 13 plus 13 is 26. And then I subtract. So this is my whole number, this is my new numerator, and this is still my denominator. So 2 and 1/13. And that's all I have for you today for notes. So please now go to your assignment. It's a short one, I think, 10 problems, a few word problems, and a few problems like this. So remember to rewrite by keep, change, flip. Keep, change, flip. All right, we out.